Hello everyone, welcome to my next tutorial 1.6 Emission Zone Fit. So in this tutorial we will be discuss about how to use Setfos for extracting the emission zone of your emissive device from a major emission spectrum. So we have already discussed about a lot of the tools and modules, but we will be now discuss in here emission zone Fit tool. Before start of my tutorial, I want to introduce myself. I am Sahil Verma, application engineer of the well-known company Impulse Technology. Our company also have partnership with Nano Academic Technology, which is Canada-based company. They offer several softwares like Nano Decals. It is used for the material and device simulations. Second one is Rescue. It is used for the material simulations. Third one is QTCAD. It is used for the solid spin qubit, and Matra, which is USA based company that used for the cloud based material simulations. And Fluxim company. It is a Switzerland based company. They offer several softwares like Setfos, Fellows. But in here we will be discuss about only Setfos, which is used for the semiconductor material characterization and their simulations. Our company provides many of the services like software distributor, training program, technical support, and equipment like micropropulsion solar cells, thin film FET, gas sensor, transistor, and memoristors. Company also have the valuable customers like IIT Madras, IIT Guwahati, IIT Dhanbad, ISER Kolkata. Many of the customers are present. We have already discussed about the Setfox tools, and we know how to put the inputs and all of the GI we have already discussed in our first video. So who has not seen it my previous video, please check out the playlist so you can get all of the information about the Setfox. And who want to more information about the company, so please check our website impulsetechnology.in. In here we will be discuss about the emission zone fit. It can be say low emission zone. So low emission zone, it is a defined area where access by some polluting vehicles is restricted or deterred with the aim of improving air quality. And second one is the process of the finding ideal parameter value that can be maximum the model performance is known as a parameter extraction. As simple word we can say, we consider complete data can be records or transferable data. They will be sent to the goal systems, then one by one at each goal columns it will be filled. So it here we will be fit the accuracy. In here we generally use for the maximize the model performance. We will be discuss at here the tutorial. In this tutorial we will be extracting the emission zone of you emissive device from a measured emission spectrums. So in here we will be create firstly a artificial emission spectrums, then we will be find the improved accuracy fits as we set the R data in one by one at the goal columns. We have discussed about the emission zone fit, but now we will be see how to we use emission zone fit tools. So click at the right side and run as an administrator. We have discussed already about the Setfox GUI, their tools, their parameters, how we can extract and how we fill inputs. So who has not seen it, please check out my first video. And one by one each of the tutorials are given like solar cells, electronic solar cell simulations, OLED. So you can see in it my previous video. It is examples and it is a layer structures. We have already told in about my first video. For the emission zone fits, we can consider simple examples like payload, and we can switch off their parameters and activate the fit emission zone. But for your better understandings, I will be show one by one with create new simulations files. Click for the create new simulations files and plus I to add more layer and fill one by one each layer names. Glass, ITO. So pedots, these layers, calcium, aluminum. So one by one we fill each layer names. So now we will be define thickness. MEH ppb for the 120 nms, calcium 20 nms, aluminum 50 nms, 0. So top and bottoms layer are semi-infinite medium. So thickness are irrelevant at here. And which layer which is wavelength dependent. So we need to define refractive index file. It will be supported .nk file formats. You can see at here the layer structures. It will be changes according to the thickness. We simply click at here and now we will be imported refractive index file that will be supported .nk file format. We have already told you about a lot of the times. So now one by one you will be imported at here .nk file formats. For the MEHPPV same file will be imported at here. You can see at here the .nk file formats. For the calcium similarly we will be imported calcium files. Click at here imports and ca.nk files. So refractive index files we have imported at here. We will be first generate an artificial emission spectrum from a known Gaussian dipole distribution. In here Setfos reconstruct the dipole distribution. Setfos also able to extract intrinsic luminous spectrums if spectral and angular data are available. So we need to activate the emission module and set the emission parameters. For the shift wavelength 380 to 780 step you can consider it here to spread source, emission output in term of photon flux, illumination spectrum, emission through filter, quenchings are given at here. In optimization settings you enable the quenching but in here you will be disable the quenchings. So you need to uncheck at here. It is already unchecked so no need to change in here. If you want any multivariable shift parameters so you will be switch off these parameters. You need to activate the emitter tab and you can see it here bulb like symbols. Now you need to import at here photoluminescence files. It will be supported .pl file formats and simply click at here open and now you can see it here file imported. Unit will be a probability. You can check at here the preview. In here you will be distribution consider Gaussian. Position will be 0.5 and width in here 30. You can see at here more settings: emission intensity, quantum efficiency, conversion efficiency and lifetime. Dipole orientation you can also see at here. Isotropic, parallel, perpendicular and customs. You need to select at here isotropic. Now we will give the name. Firstly, you need to create the synthetic emission spectrum by pressing the run button in the toolbar menu. Now you can see at here the results. color diagram, exciton density, radiating dipole density, radiative rate profiles, refractive index, absorption, reflectance, transmittance. For the spectral emissions, you can see it here the emission, normalized emission, white emissions. In the presentation part, we have already told about that we need to record complete data or transferable data to send the goal systems that put in one by one each goal columns. So it will be used for the maximize the model performance. At similar we will be recorded. Now you click at the right side and data and save visual data. Click at here the workspace. Now you can save your file. Now you need to activate the fit settings. It is used for the emission zone fit settings as you can see it here. That files you have saved in the workspace you need to import at there. You can see it here the similar files, spectrum. Now you can simply import their files. Here you can see at also advanced fit settings, stack luminescence spectrums, number of fit sampling points. In order to improve the accuracy fit, you need to select at here the number of fit sampling points. You can select at here 150. It totally depends on you which number you want to select. You can see at here the smoothing order, smoothing factor, number of iterations, minimum relative change, and increment. If you want to shift any parameters, you can simply click at here and check at here that parameter you want to shift. You can easily shift. At here, you need to data column set to 2. If you want to change the emission spectrum, unpolarized, X-polarized, P-polarized, SP-polarized, so you can easily change at here. You can see at here the script modes, and if you do any mistakes you can easily check in here. It is a console view and it is a result view. Now emission fit zone, you can give new name in here and simply click at here the play button. So you can see at here the emission zone fit parameters. Emission zone fit tools use at firstly we create artificial emission spectrums, then we activate the emission zone parameters and get accuracy fit results in here. In my presentation parts, we have discussed about the complete data and transferable data. So we select and one by one we put at here the goal column. That's similar meanings in here. It will be parameter extraction, as simply we can say we will be used to increase the model performance. So you can see that here the comparison between artificial measured emission intensity spectra and the fitted emission intensity spectra. So a nice fit. The spectral dipole distribution is similar as say as assumed dipole distributions at here. Similar you can see it here. So Setfos in here reconstruct the dipole distribution as you use the generate artificial spectrums from a known Gaussian dipole distribution. So I hope you understand how we can use fit settings tool. It generally used for the emission parameters extractions and got the accurate results which can maximize the model performance. It gives the set goal value. So I'm going to end here at my tutorials. If you have any query about this, you can simply ask in comment box, or you can also contact us through the email given at the description box or at the end of my video. If you want to book demo, go with the impulsetechnology.in So thank you very much.